Hello, welcome to SurvEng Calc Part 2. The reason for SurvEng Calc Part 2 is because I've actually added some more procedures to the application itself. And these procedures are, I'll just show what they are now, is ref line, curve horizontal, horizontal curves, curve vertical, straight horizontal alignment, elevation string, and area by coordinates. And I'm going to go through each one by one, just to show you exactly how they work. So the first thing I'm going to go into now is ref line, which is this one here. As you can see, I've already put the coordinates in for the ref line itself. If I just go do a reset, um, the reason why there's no sort of labels above the text boxes there, or the input boxes, is because I've actually got them written inside the input boxes themselves, but they get wiped out as you enter the coordinates. I'm just going to put a little picture into the display here. So I'm just going to pull this one in. Okay. This is basically explaining what refline's all about. We've got two sets of observed coordinates. This could be something that's in situ outside. It could be a wall or something, and you want to set some points out relative to a wall, a straight line wall. So the best thing to do is just go out there, survey the start and finish of the wall, for example. So you've got start coordinates, ending coordinates, and what you can do with the ref line with these coordinates here is plug them into the application, and it will give you a bearing and a distance between the 2 points, and from that you can actually work out coordinates to set out from the wall itself, or you can set out by distance and offset using distance and offset to the point. So that's what refline's all about. And just to clear up a little bit of confusion, anything to the left hand side of the line, this side here, is considered a negative value. So if you've got an offset from here, the distance is obviously going to be a positive, but the offset is going to be a negative value. And on the opposite side, it's going to be a positive distance and a positive offset. And if you're going past the ref line itself, or you want to extend it, that's going to be a positive that way. And if you want to go before the ref line starts, which you can do in the app, that's going to be a negative. So you could have a negative distance and a negative offset, and again a positive distance and a positive offset. Or you could have a positive distance and a negative offset. As long as you know what you're doing with those, then you're going to be fine. So I'm just going to pull this out. Okay, I'm just going to recall these coordinates. So I'm just going to go call up. Everything's saved. So once I put the coordinates in there, I'll just hit save, and it will just save those. I can use those again at another time if I want. If I want to call them up on the mobile device, they're always there. So what I'm going to do is I'm just going to I want some coordinates now. So this is what I want. I want the eastings and northings. So I'm going to check the eastings and northings box, and I'm going to put in a distance of, say, 15 meters. And then OK that, and I'm going to put an offset of 15 meters as well, which is, both of these are relative to the ref line. And OK that, I'm going to go calc, and that's the coordinates for the distance and the offset that I've just put in relative to the ref line. And what happens is this box is automatically cleared, because that can always change, but usually the offset stays as it is. So I'm going to put another offset in there. I'm going to put 50 meters in there. And this box that you've got coming up here is basically so you can see what's been written in the boxes underneath the keyboard, because it does cover them up. So I'll put this one here just so you can see what you're doing. So I'm going to put 50 meters in. Okay, that, and calc. And there's the coordinates for the distances and offsets that I've just put in. Now I can just press print, go there, and there's the coordinates there listed down there. Okay. So I'm just going to go back. It's gone to 5 and 6 because I did have some coordinates in there previously that I've actually deleted. So, but it would number them 1 to whatever you put in there. Okay. So we know that works. So now I want to do I want some eastings and northings. So what I'm going to do is I'm just going to do a quick reset there. I'm going to go call up. I want uh, I want distance and offset, so I've got to put some coordinates in. So I'm going to re-enter some of those coordinates back in. So I'm going to put coordinates of 19609, 7.750. Okay, that. This one here, 51, 471. 51, 471.370. Okay, that. Okay, Calc. If you remember, that's what I put in to start with there. 15 meters for a distance and 15 meters for an offset. We'll do another one. We're going to go 196097. 6097. 750. And offset 51506.379. Okay, that. Calc. And if you remember, I'll put a distance of 50 in and an offset of 15 there. And if I go print, there we go. There's the distance and offsets written there. So you can do either. You can either get eastings and northings out of the ref line, or you can get distance and offset for setting out. And basically, that's all that is just for getting distance and offset and eastings and northings relative to a ref line. Years ago, you used to get ref line come as standard on Leica instruments. You didn't even have to pay for it, but then they started charging for it after a while. But yeah, you can do it on a mobile phone now. So we've got that. And if you get stuck for any information, the information's all written down there anyway. So I've got a full set of instructions there. Anyway, that's the ref line done. I'm going to go back here. I'm going to go to curve horizontal. For horizontal curves, I'm just going to dig out a picture for that, just to do some explaining. I'm going to drag that in. Okay, I'm going to pull that into there. Okay, with horizontal curves, we've got a left-hand curve, which is if you stand here, say that was zero chainage and you was looking this way, a left-hand curve obviously veers around to the left, and a right-hand curve veers around to the right. So we need to remember that for the program. Now, with the offsets for the curves, you don't have to worry about negative values or positive values. Okay, so they're always putting as a positive value. Okay, so just remember that. And the other thing to remember with a left-hand curve, when I talk about offset left, then the offset is on the inside of the arc, and when I talk about offset right, that's on the outside of the arc. Whereas on the other hand, for a right-hand curve, offset left is on the outside of the arc and offset right is on the inside of the arc. And both offsets are input into the application as positive values for both hands of curve. So that's just something to remember there. And if we look here, I've already got the coordinates and that loaded up, because it just takes a little while to key in coordinates with a virtual keyboard on a computer and a mouse. So there's my sets of coordinates. That's for the beginning of curve. That's for the end of the curve there. Okay, I've got the radius there. I've got a start change there. You can put whatever you want in there. I've just left it at 0. And we're going to have an interval of 10 meters. So it's we're going to have an interval of coordinates every 10 meters along the curve. And I've left the offset as 0. So on here, you've got a left-hand side offset and a right-hand side offset. If you don't check those, then it automatically assumes that you want the center line of the curve there. So offset 0. And obviously there's your curve direction there, left-hand and right-hand curve. So if I just go to Calc here, what that does, it gives me the curve length and the curve end chainage. And obviously if we had a start chainage of say 500 there, that would be 759.584 there. The chords we've got there, the setting out chords are 26, so that's 26 points at 10 meter intervals, and the last subchord there is 9.584, so that's the very last point on the curve there. Now if I just go print, it's asking me to move orientate the device to landscape. So if you had a mobile device there, you'd be moving that to landscape because it's not very wide on here. So I'm just going to pull that out just a touch there. So if we can see that here, we've got the center line of the curve now with all the coordinates going right the way down the chain edges, or right the way up the chain edges, I should say, to the very last one, which is there. So that's basically the change in offset for the center line of the curve there from the information provided. We go back here now. Now what I want to do is I want to offset left. And what we have to do, which I should have said to start with, is every time we put the information in there, we have to save it. Always hit the save button once you've entered your information there, for two reasons. One is you can always call the information back up again at another date and use it again, and it even saves the settings there. The only thing it won't set is the offset because that's too variable and it could cause some confusion. So always press the save button. And the other reason is because every time I want to do a new calculation, I have to reset there, then call it back up. Now I can go and do the left-hand side offset. And the simple reason is, if I didn't do that, because it saves information, it will save this information as well, and it will get jumbled up with the last lot, with the center line. So always hit the reset, call up, and then if you want to do an offset, go offset here, offset left, and we'll give it a value of, say, I don't know, 25 meters, 25 meter offset, and just go calc. It's the same as what it was before on the center line. That doesn't really change. And if we go print there, don't worry about that. Now we're going to get the right hand curve offset left. So there we go. That's that's basically all the coordinates there. I'll just go pull that out a little bit more there. All the coordinates for doing an offset left, the left hand side offset. So I'm going to go back here. I'm going to go reset, call up. I want to do right hand side offset now. Again, we'll do 25 meters again. Go OK. Count, same information. And just go print here. And there we go. We've got offset right now. All the information for offset right, which is there. And that's it for a horizontal curve. Again, all this information, the same as in part one, you can just highlight all the text, then use your device's share function to actually upload to Google Drive, or you can email it to yourself or send it out as a text message. I find the best thing to do is just email it, because you can just copy it straight off of email, crank it straight into Excel, data in your tools, text to columns, and you can fill around with it in Excel. But simple as that. So that's basically like a curve alignment there. So again, you can save it all and call it up at another date. So if we just go back to home, we're going to go to vertical curves now. Okay, this one, metric units only, I'm afraid, for now. I will do something for our American friends, but I'm at the moment I'm just thinking in units, and I needed to get this done quick. So for a vertical curve, this will do any type of vertical curve where the tangent lines are considered equal in length. So if I'm just going to open up this here and pull this into frame. Typical crest curve there, typical sag curve there. You got type 1 crest, and then you got your type 2 crest curves. So with your type 1, it starts off as a positive, ends up as a negative. Then with your two type 2s, it can start off as a positive and finish off as a positive, or start off as a negative if you're going down and finish as a negative. Then you've got your type 3, which is your sag curve there, which starts as a negative and ends up as a positive. Then you've got your two type 4s, which can start off as a negative and finish as a negative, or start as a positive and finish as a positive. Now this curve application that I put in here would do all of these ones there where the tangent lengths are considered equal in length. You get other ones there which are not symmetrical, and they're basically two curves, so you have to work them out separately. But this will do all of those. So I'm just going to pull that back out. Okay, I've already got some data saved in there. I'm going to call this up. This is a type 1 crest curve that's been put in there. So uh, what you've got there is you've got your percentage in, you've got your percentage out, you've got your start chainage, the interval where you want the levels, so that's every 30 meters. The IVP point is where the point of its intersection of the two tangent lines, and the curve length is 170 meters. That's not around the curve, that's a horizontal distance between the beginning of the curve and the end of the curve. So that's that there. Again, you can save all the information. I'll call it up at another date. So if I just go calc, you'll see it there. And there you go. There's all your elevations around the curve. At that, and if you scroll down to the bottom there, you've got your low point, high point. Because this is a crest curve, that's going to be your high point there. So at chainage 370.238, you've got a level of 547.316. That's the high point for a crest curve. If this would have been a sag, that would have been a low point there. Not too much to say about that. It's quite simple really. So if we go back to home, straight alignment there. Okay, this is basically a straight alignment. I'm just going to pull something into screen there if I can find it. Okay, let's see that. Pull that in there. Okay. So what I've got here is just two sets of coordinates, and from these two sets of coordinates, I want all coordinated points on chainage at certain intervals all the way along here. So I can do it along the center line, or I can do it at an offset from the center line here to the left or here to the right. Again, with this one, you don't need to enter negative or negative, worry about what the signs are. They're both going as a positive if you're doing an offset left or an offset right. So just the starting coordinates, end coordinates, choose whoever you want to do an offset, and it will give you all the coordinates along that point at your required interval. So if I just go call up, there's my starting coordinates, there's my end coordinates. I'll start chainage, I've just put 0, put interval of 50. I'm doing center line, so I don't need to touch anything. I just go calc. There's the bearing and the distance between the 2 points. And if I go print, there we go. There's all the coordinates on chainage through the center line. And again, come back. I'm going to reset, call up. I do offset left. The value of, I don't know, 20 meters. Just anything really. I'm going to go calc. Same bearing and distance, doesn't make any difference, except for you get the offset left at 20 meters there. There you go. Go back. Reset. Call up. Offset right. I don't know, do 10 meters if you want this time. Go calc. Same bearing and distance. Print. And there it is, offset right, 10 meters. And that's that. So that's quite simple really. That's easy enough to understand. So if we go home, I'm going to go to elevation by string now. Okay. Basically, what this is now is you've got a choice of either having two levels, the percentage, or a grade. And what you have is a starting point, which will be level 1, or which would be a starting point. And if you're using percent, you'd need to know the percentage of the road or whatever it is you're doing, or the grade. So I'm going to choose two levels. I've already got them in there. I'm just going to call it up. So basically, I've got two levels. Starting chainage of 0, and the distance is 568.653, and an interval of 50 meters. So between those, I want to know what all the levels are between those points there. So if I just go calc, and there it is there. There's all my levels right the way up to the end chainage there. So what I could do is I could say I want to know what it was using the percentage. So I could go reset. I'm going to go call up. I'm going to get rid of that one there. I'm going to clear that one. And I'm going to go save and reset, call up. I'm going to choose percentage now, and that is 33.123. Let's give it another one. So basically that was a 1 in 3, so which is 33.33%. So I'm going to OK that, and I'm going to go Calc, and as you can see it's the same. It'll be the same there. I can do the same for the grade as well. I can do that, reset, call up, and now I'm going to go for grade there. So I'm going to just put 3 in there. So it's a 1 in 3. Okay, that. I'm going to go Calc. And there it is there. So you've got a choice of how you want to do it, 2 levels, percentage or grade, and it will basically put levels. Say for instance, what we've just done there, we've done that horizontal alignment with the offsets. You could put all levels on those now from doing that, and that's what that is. Okay, if I go to home, choose procedure, area by coordinates. This is pretty simple really, area by coordinates. I'm just going to see if I can load something up into here. Find a picture somewhere, which I can't. Just have another go. Here we go. Area by coordinates. Okay, so we've done a survey. These could all be control points going around a site for all we know, and we just want to know what the area is. All you have to do is just number them 1 to n, n being the amount of stations or points that you've got going around the area. And once you've got those coordinates there, all you have to do is put in the quantity of there. So that would be 5 points, and then you just put the easterns and northerns there. I'm not going to do this because it just takes too long with a virtual keyboard. So you've got 5 sets of points to go in there. Then for each point you put your east and your north, and you press enter, and once you pressed enter, these 2 boxes will clear, and you put your next points in, enter, 0.3, enter, 0.4, enter, 0.5, enter. Then what this does is this will count for each press of enter. When the count reaches the quantity of points that you've got in there, it will automatically calculate the area and the perimeter of the coordinates in there, and then and that's it. And then what you can do is you can press print there, and it will give you a list of the coordinates that you've input in there, so you can check your coordinates off, and it'll also give you the area and the perimeter values that have been calculated from the coordinates. So the good thing is you can actually check your coordinates to make sure that you printed them in correctly. So if you made a mistake, you can just press reset and do it again. But yeah, that's and that's it. Well, folks, that's SurvEng Calc Part 2 finished. So hopefully that's okay for you. There's more to come. I'm going to do some more curve work on there, probably some more fancy curves, maybe some super elevation and spiral, and I'll also make room for scale factor as well, I think, next time. So more to come. Thank you very much.